And now we will move to the topic of microgrid. It will be presented by Nabil Sahri from Sagemcom. We can say in some ways that Nice Grid or Nice Grid project was a kind of microgrid because we've been islanding a part of the electrical system for some hours, 5 hours. But now we'll go more deeply in that topic of the microgrid. Please, Nabil.
So thank you, Valériane, for the presentation. So my name is Nabil Sahri. With Sagemcom, I'm Vice President for Business Development for the energy activities at Sagemcom. So I'll talk about I would say, the lower end of the microgrid, as you will see. So in fact, the microgrid is a vast topic, as you know. So there are different segments. And at Sagemcom, we are focusing on I would say, the few megawatts or less than few megawatts microgrid, what we call mini grid. So you will see in the presentation our experience in this area we are doing since a couple of years now. So let me start by presenting Sagemcom for those who don't know it. So Sagemcom is a French-based international group. So we are focusing on 3 main areas, as you can see. We are in the broadband area. This is in I would say, the home area where we supply devices for DSL connectivity, internet connectivity, but also TV set-top box. We are also active in the energy and telecom, which is where we have the smart grid activities and the nano grid or mini grid activities as well. And we have a third pillar, which is the Internet of Things. So we are roughly 70 years old company. We used to belong to a company called Sagem. Indian people know with the cellular phones we used to sell here. And so we are 40 years. We have 40 years experience in telecom area. So these are rough figures. So turnover is 1.85 billion euros last year. We have 4,000 employees. We are operating in 40 countries. We focus on our own R&D, so we have more than 1,000 engineers, most of them based in France, in our headquarters close to Paris. And we are also manufacturing our devices, so we have experience in manufacturing. We ship more than 25 million terminals per year. So we are vertically integrated from the design of our products to the manufacturing. So in the energy and telecom segment, these are the 3 areas we focus on. We are a major player in smart metering. We are also active in the smart grid, so to integrate different energy solutions for distribution networks, and also for the smart IoT. So let me start to give you where we started to develop these solutions for the mini grid. So our background in telecom, in fact, helped us to get in touch with the telcos in developing countries, like in Africa, for example, where there was a specific use case to power and to monitor the power of the telecommunication base stations. So these are usually remotely located on off-grid sites. And so the idea was to create a solution to get off the diesel generation, which was powering these antennas and these base stations, and to provide some local generation. So this is what we call the nano grid solution. So you are connecting just one site around the telecom tower, and so it provides security for the telco to power his base station, and also security of the site because we have some remote management with cameras to see if someone is stealing, for example, the diesel or something like this. So from this solution, we extended because there was an excess of power. So as you can see, it enables few watts to 12 kilowatt capacity. So this excess of power was used to power neighboring villages and neighboring houses. So we went up to the few megawatt peak power generation to extend this electrification to villages. And this is what we call today the nanogrid rural, like I will show. So this gives you some ideas of the solution. So you have PV to generate the electricity, and then you have a complete industrial solution, which is managing the storage, the battery, but also the communication. So the idea, in fact, is to for the telco to create more value, so to add new service to besides the telco, I would say, services, to have a very cost-effective solution to power these towers, but also to have a brand image. So we are working, for example, with Orange in Africa, deploying thousands of this kind of sites, and it helps to improve the image of the telco with I mean, socially among the population. So it's completely, I would say, automated solution and easy to use. And so we decided then so this gives you also some pictures, yes, of what we started. So this is the Insight, I would say, equipment with again, the batteries, the inverters, and so on. And on the outside of the site, so you have some power plugs with AC outlets to power some devices, so on the customer side. And we made use, for example, in Madagascar, even to power some theaters or some music areas for the population together, because these were unpowered areas or powered just with some small generator. And so this brought some new activities also in the villages. So going from the nanogrid, we decided to extend to the mini-grid rural, what we call mini-grid, which is up to few megawatt, I would say, capacity. And the idea was actually because this solution were already existing, but it was mainly developed by ONGs or by small players. And our idea was to industrialize the solution and to make a turnkey solution to implement within villages which are off-grid. So there is the power station itself. So for with the PVs, for example, or now we are also implementing some fluvial hydro to turbines to generate the power. So we have also the distribution of the different application. We go to the connectivity as well. So this means that we do civil works to deploy, to lay down the cables and to power the end customers. And we provide also the communication and monitoring solution, which is a software solution to be able to I would say, control and to manage this infrastructure. And we provide also the maintenance and operations. So it's a full turnkey project, and it's a real, actually, mini smart grid. So this shows again I would say the generic solution where you have the PVs, and under them you have all the network inverters, the batteries, and also distribution cabinet. And as I said, we can go up to few megawatts with this kind of solution. So, as I said, our idea is to industrialize this solution at maximum. So we found some difficulties sometimes in building this infrastructure locally, because you have, of course, to rely on local workers who are not very well skilled or very well trained, and also there's some safety issues you can face. And so we decided to make what we call a power shelter, which is a complete shelter, like you see, which is, I would say, hosting all the equipment, which can be pre-cabled off-site and then brought to the site to manage, I would say, the solutions. You have just to install the PV and then to put this shelter on site to start operating. So it helps to reduce the cost, of course, because you are doing this in an industrial way, in some off-site, I would say, warehouse or something like this. And it's also a replicable solution, so you control also how the solution will operate over time. So this is also learning we got from the project we are deploying. In fact, there is no point, in fact, of providing a maximum capacity from the start because of the cost. As you understood, these solutions are deployed in villages, mostly in Africa or in Asia, where the cost or TCO is a key parameter. And as I said, between the solar home systems, which are, I would say, $300 or $400 the site, up to the solar farms for the microgrid, which are in the millions or $10, $20 million, we are sitting in something around $100,000 to $150,000 site. So we have to be very cost effective. And the idea is, in fact, is to provide different level of services depending on criticality of the equipment to monitor. So if, for example, it's a mission critical equipment like a telecom tower, so you have to provide high power and high priority with a high availability. But maybe you don't need, for example, for some houses to have 24 hours power in the house. So you have to manage the level of power you need to give to this or these subscribers. So the idea is to have an automated system, which is controlled by what we call the ESM Vision. It's our software to, depending and based on the application or the service you want to deliver, you can actually deliver the right power to the endpoint. So this helps us to reduce the cost of these solutions drastically. As you can see, we can have a 20% reduction, for example, in some cases, with an optimized solution. Okay, so this is just what I said before. So we are, in fact, deploying the infrastructure from the medium voltage to the low voltage. We do all the civil works, as I said already. So for the connection of the subscribers, you see that 75% of the connections are for low power households. So in Africa, for example, this is experience we gained. People don't need a lot of power. We are talking about 100 watts per day to manage light, to charge their phone, to have a small TV or a fan, for example. And the idea is to use a DC equipment to reduce the power consumption and to increase also the number of subscribers you can connect to the grid. Then we have the small shops and the small industries at this scale, of course, which represent 25%, where you can add some fridge, for example, if it's a shop which is selling some meat or some food, or some fish or some meat, sorry. And you can add some, then in this case, some AC connectivity to connect this fridge or these equipments. Then we have the telecom site, so where we are, or some industry, high power industry, where we are connecting to three-phase AC power directly. So in terms of subscriber connections, so this gives you different solutions. You have, as I was saying, I would say the low power, where you are using a DC distribution box to deliver just the amount of power which is needed for charging a phone or some LED lighting or so. And then go down to the full AC distribution, I would say, where you have, as I was saying, more intensive, I would say, usage of the electricity. So this case of DC distribution box is also interesting for our customers because they are not delivering the service based on power count, I would say, but they are delivering a service, which means that they the subscriber can subscribe for an amount of power based on number of equipment he's using. So it can be, for example, just to charge his phone and his light, and he pays a monthly fee, a full service, which enables him to get this. So the system is able to control all this automatically, and as I said, optimize the distribution between the different type of users, which makes also the solution very flexible and very, very efficient. So this is what I was saying about DC box cabinet, which is actually coming after an AC distribution board. So if you want to add later, you need more capacity within the house, you need to plug a fridge, for example, then you still have an AC outlet on the distribution board where you can come and plug your new device. So in terms of metering is very important because, as you know, you need to incentivize and also to manage the service from the revenue point of view. So in most developing countries, a prepaid solution is actually used because people prefer to know how much they will consume before activating, I would say, their power. So we use STS solutions, either non-connected using a keypad, or with a remote connection, which means that the end customer does not interact with the meter anymore. The tokens to activate the system is automatically generated. So, of course, the meters have some latching relay to open and close the meters. We have also solutions with top of the pole. This is more for to control, I would say, to use anti-tampering solutions, since the meter is completely off-site of the end user.
1 minute, please, Nabil.
So I'll finish about the selling process. This is also very important in these countries. As you know, for example, in countries like some countries in Africa, mobile phones are very popular and more diffused than the fixed lines. And so we have a full solution which is based on a mobile money solution, which enables the subscriber to recharge his electricity directly over his phone. So it's a standard solution again, which can interact directly with the telco to enable the delivery of the tokens. So I will just show you some graphs about this is the control dashboard of the system we deliver as well, which enables you also to have a full view of the mini grid. Also in terms of consumption, so you can control consumption daily or hourly based. And these are few examples of realizations where it shows you a little bit the type of solutions we are developing. I think I finished, so thank you very much.
Thank you. So 2 questions in the room. Yes.
Hello, Laurent Carcentri from Enedis. This kind of solution, nanogrid or microgrid, has one point that is, according to me, something to look at, is the battery and the battery policy. What kind of maintenance battery policy have you got for this kind of offers? Is it a delicate point?
We are deploying actually these solutions since now 5 years. So we don't have any issues, I would say, to report about the battery maintenance. There is a specific knowledge about which type of batteries, of course, you need to use per area. What I can tell you is that the maintenance is used by local teams. So we are, in fact, once we deliver the solution to a village, there is a dedicated team, usually is the village guard or someone in Africa, who is managing this. So the level of maintenance is not that high for this kind of solutions. This is what I can say.
Another question, maybe from the Indian side?